welcome to the new video. So I was recently working on creating a game using Python. If you have seen my previous videos, you must have noticed that I try to make videos around Python and its use cases. So this is another video where I was just trying to recreate one of the games that we used to play back in the days, which was a snake game. I believe everyone must have played it. So this is what a final output would look like. This is a snake, and this is the food item, and this is the scoreboard. The functionality that we are trying to build is pretty straightforward. The snake randomly appears anywhere when the game starts, and then it just goes ahead. You can use arrow keys to move it up, down, uh, forward and backward are usually taken care of, so all you have to do is move up and down, left and right. And then as it consumes the food, its size increases, and then food also randomly appears anywhere in the dashboard as and when you consume it. And after a certain time, if you hit any of the outside walls, the game gets over, and as and when you keep consuming the food, the scoreboard keeps increasing. So this is what a final output is going to look like. Now, in order to showcase this, I've already done all the logic here, but I would really like to show how we have divided all the functionalities, all the features, segregated it into separate entities, and how each one of it comes together into creating this game, into creating this output. So if we start with looking at the requirements.txt, I've used nothing except from the pygame. Pygame is the library which helps you create these layouts and helps run the game. Then in order to achieve this, we have created file for each and everything. So this is a food, so there is a food.py which takes care of all the logic of creating this food. Then there is a snake which takes care of this component. Then there is a scoreboard which takes off this component, and then there is settings, which is kind of common, which has settings for all these three. And game.py is where everything comes together and gives us this output. So we'll have a look at each and every one of these things. Let's start with food, how the food is generated, and I'll also load the settings because that's important. Let's look at the food setting. There is only one food setting which is mentioning that it should be of this color, and that's the red color that we have showcased here. And if you look at the class, it's just so every component that you are going to create has to be inherited from this game class. This game is coming from pygame itself, and in order to do that, yeah, let's look at food. So first we have incorporated the settings. So this is the settings which is coming from, you can see, the game dot settings which we have mentioned. And then there is a screen which is again coming from game dot screen. This game is part of pygame, so if you exclude this import, you will start seeing that this game will start giving an error as soon as you click it. But the game dot settings and game dot screen is part of the parent class. Now this is a function where we draw the food. Everything in pygame is actually a rectangle, no matter what that shape is, but because it deals in pixels loading, it always considers everything as rectangle shaped. So it's drawing a rectangle, it's drawing the food on our self draw screen, which is this game screen, and it's loading the settings from our settings. It's getting the food color, it's picked up the settings from self.food color, and then pygame.rectangle. So we are actually asking it to create a rectangle. So this one has parameters that this should be the left, which is food 0, then top should be food 1, and then width and height comes from our snake cell size and our snake cell size. So if we go to the settings again and you look at the snake, we have snake second, yes, snake cell size 20. So what we are trying to say here is 20 pixel is what we wish the food to be, because it's a square, and snake is also couple of 20 pixel loaded together. I believe that's 3, but we'll look at it further. So so we have mentioned this thickness or the cell size as 20, and we are utilizing the same to load snake as well as the food. So food ends here. Then what we load is the snake. The snake again, it's calling the parent method, and then yeah, this is coming from the inbuilt classes. Then we are loading the settings. We are getting the screen where we are going to load it. Now snake has two functionalities. One, it should get drawn, and the second one is it should run. So drawing, again we have a snake head, which will be part of the input. For segment and snake head, it will be an array specifically saying where exactly should that snake appear, and we are drawing it on the screen with the color that we have mentioned in the settings. We have snake color, and then we are creating a rectangle, which is left is this, right is this. We have a snake cell size. Again, snake cell size is 20, and it's going to be a 20 cross 20. Then the functionality for snake is to run. So we always mention, so whenever you are asking it to run, you always have to pass two parameters. First is where is the starting point for that snake, and the second is in which direction that snake should go. So that's what we are passing. We are passing the snake head, which is the current position of the snake, and the snake direction. So we, from the snake head, because it's an x and y coordinate, we take x y, we add a new head, because snake direction is again direction in terms of x or y. So we are incrementing the x-axis, we are incrementing the y-axis, that becomes the new head, and then we are assigning the new head to the current snake head. So this run functionality keeps going on in kind of a while loop. We'll showcase the while loop, and so with every second the snake keeps progressing one step further. Then scoreboard is pretty simple. We have a screen, again rectangle, settings, text color, font. We have a preparation for score, so we have a snake length. So every time we are getting snake length, because that's how we are calculating the score. This logic is straightforward because we initiated the snake with a length of 3. So as I told, these are three 20 pixels put in together. So whatever is the current length of the snake minus 3 will become our score. And then we have a score image. Score image is just rendering the snake length in a particular color. So whatever is the calculation of this integer, we are showcasing it, we are rendering it. And then we just get the score image as rectangle, so that we can set the right and the top width, just to make sure it is where we want it to be. So once we have, so we are calling the show, which prepares the score, and then just screen dot blit just showcases uh, on the screen. So blit is when we want to put something which is static, which is not moving. So now that all these components are done, the final thing which puts all of this together is our game class, and we initiate a pygame instance. We get the clock from pygame, we get the settings from our settings class. We have a screen, so this is the screen that we are creating. We are creating a screen of screen width and height, which we have mentioned in here. So it's a width of 1200 and the height of 800. Background color we have mentioned, black color is just for repurposing. Border thickness and game speed, so you can keep on increasing the game speed as well. In case you want to put a scenario where after achieving a certain uh, score, you increase the speed, which increases the complexity of the game. So in for starting, we initiate the snake head as the default segment. Default segment is literally the x and y axis of where those three segments should appear. So if you notice, the y remains the same, the y remains the same, and the x changes 60, 20, 80 and 100 at a gap of 20, because those 3 pixels are getting rendered at x-axis 60, 80 and 100, and because they are 20 pixels, so they all seem to be like in one straight line. And the direction, we have a default direction. which is x-axis is increasing, so it's going in like left to right direction. And then we have a new food. We always get the method to create a new food, because by default as soon as the game starts we need a food item. And we have a default scorecard. So scorecard, we mentioned that the default value will come out to be 0. And then we set the caption. This caption is nothing sorry, but what we see on the window. And the background color. This is where the magic happens. We initiate the run game and waits while true. While true, because we want the game to keep running in a loop until there's been a scenario that the snake has hit the wall. So that scenario will be checked under the check events, and if the check events suggest that you need to exit, you exit. Otherwise you keep updating the screen. We keep rendering the screen with new or the increased score, increased size of the snake, or a new food item. Then this check events, which is being called here, it checks all the event. We are currently only handling key down events, so because it's a snake game we only need arrows. And so what we are doing is get the events, basically get the keyboard events. And if someone has pressed quit, which is like the q index, it exits. If someone has pressed a key down, any key is pressed, so we check which key is pressed. So we are currently handling only some of the key events. If someone has entered K or Q, we exited. If someone has entered, sorry, not K, Q, it's a key which is Q. So if someone clicks on Q, the game ends. If someone clicks on key down and snake direction is not towards the end of the game, then it goes into other direction. And someone has pressed up and it's already not the case, then it goes up. If someone has pressed left and it's already not going left, then it goes left. If someone has pressed right and it's not already going right, then it goes right. So that way we check the key event that's happening and move the snake into that particular direction. And then the update screen is just fill with the background color, draw rectangle, we create a snake and run. Create snake and run creates a snake instance. Run the snake and keep drawing the snake. And then we have a create food event. Create food is you create a food, you draw a food, because you'll need to create it again and again. You check if the food is being eaten. So this is interesting. So as soon as this event gets checked, we check that if snake head is equals to new food. So basically if your snake has reached to the pixel where the food exists, that's when we create a new food. And also we increase the snake head, we increase its length. And we definitely create a new food item randomly, creating it on anywhere on the screen. So this is just a random function randomly generating x and y axis, making sure it's together so that the food is created as one pixel. And where was this getting called? Check if food eaten and show score. So we want the score to be updated in real time. So what we do is, where was this show score? Okay, this is coming from scoreboard. So just rendering it. We have a display flip, we have a tick, because we want to make sure the game speed is mentioned. When you say tick, game speed, the front end which is rendering to you gets refreshed every 10 with the unit of 10. If you keep increasing it, you'll see that the game is getting refreshed, or the pixels are moving faster. This is for checking collision, so that if the snake either collides itself or it collides the wall, then you end the game. So it's just checking. If you have collided yourself, then end the game. And if you have collided to the wall or itself, then you return true. And if it's not a collision, you return false. So if it is false, it does nothing. If it's true, it shows that game is over. It's just a message. You quit the game, you exit the system. So, and this is where you initialize or start the game. This is pretty common for someone who's working with Python. You create a game instance and you click on the method run game. So now let's see what the output looks like. So yes, the game has started. As you can see, it the default. Let me end this and start again. So notice one thing: as soon as the game starts, the food is at a very random location, but the snake is always going from left to right and always start from the same location. Let me end this one more and see the snake always starts from that one position from here. Let me end this and see the snake always starts from that one position. The food may be anywhere because that's randomly generated, but yeah. So let's start again. So right now it has 3 pixels or length of 3, and now I've eaten one, so you can see the score is also 1, and the length of the snake is 4. I'll eat one more food, or snake will eat one more food, the score becomes true, the length increases, one more, score becomes 3. I just want to increase its length up to a point that it's very significantly visible that the snake has grown in size. So it's 6, then 7, oops, and 8, 9, 10. So now it's easily visible that the snake has grown in size. Now in order to end the game, either I can just leave it, it can collide to any of the calls on any of the walls, or I can just make it collide to itself. So let me try to make it collide to itself. Yeah, so game over, it games over and quits. So quit is when we exit the system. So it quits, we exit the system. So yeah, this was an interesting uh, use case of playing the game, especially because almost all of us have played this game in the past. So it was fun to create this. I will again, as usual, I will check in the code. I'll mention the repository in the description of this video. Go have a look and let me know if you suggest creating any different game using the pygame library. All right, it was really nice. Thank you so much. Have a good day. Bye.